Okay, let's talk about performance. So assume that I give you a list of returns that look something like that, and I have more of them. I'm going to have a total of 60 observations in this, but just to show you a few of them, these are the dates. So this is monthly, here's the portfolio, this is what you're managing, and this is the market. So what we have here essentially are the returns from your portfolio equal alpha plus beta of your portfolio times return on the market. And both of these columns, the portfolio and the market, have the risk-free rate subtracted from them. Okay, so when we do the performance, let's go back and do these in kind of the order they were invented or discovered or whatever you want to call it. So we have the Sharpe ratio, which is going to equal the return on the portfolio minus the risk-free rate over the standard deviation of the portfolio. Of course, that's the same thing as the capital R over standard deviation of the portfolio. I'm not going to calculate that here because all you have to do is take the average of this column and then take the standard deviation of that column and the average, because the risk-free rate's already subtracted, the average of this column, and then you really should have the standard deviation of the portfolio returns without the risk-free rate subtracted. So let me say it should look like this. Take the average of this column, and then you'd want to have another column that was the portfolio. Remember, this is, I should put minus risk-free rate, just the portfolio returns. Take the standard deviation there, that standard deviation, that average. Okay, 2, I want to do the trainer measure, which is going to be excuse me, the excess returns over the beta of the portfolio. The excess returns, we found that average right here, the exact same one. The beta of the portfolio is right here, so it would be this divided by 0.5961. 3, we want to find Jensen's alpha. Jensen's alpha is the same as the alpha from this equation. What should alpha be equal to? Well, if the cap M is true, then the return of the portfolio equals the beta of the portfolio times the excess return on the market. There is no alpha in that, so this alpha should be equal to 0. So we run the regression and we see alpha is not equal to 0. If I want to annualize that, just to think in annual terms, I would multiply that times 12, and then I say, well, is that just randomly above 0? So I look at the p-value and see the p-value is very low, so no, it's significant. So what I would want you to do on an exam, and we have a couple more things to add here, but on the exam I would want you to be able to tell me from this information, what's Jensen's alpha? Well, Jensen's alpha is 0.0150. I might say I want you to annualize that, and you know it's monthly data, so you'd multiply it by 12. And then the trainer measure, and what I would have to do is I would give you this output and you would have to recognize that the beta was 0.5961. I wouldn't expect you to get the average of this entire column, so I would have to tell you the average returns were, I don't know, whatever, 15%, and the risk-free rate was 2% over that time, and let you do the math. Same thing here. I'm not going to make you calculate the standard deviation, so be that simple. Alright, number 4 is going to be what we'll call the Fama French alpha. So let me pause the tape here and give you some more given information. Okay, so I'm back with some more given information. This, which you can't read, is the regression output from before. So now I'm going to do the 4th thing, which I'm going to call this the Fama French alpha. The return on your portfolio should be equal to alpha plus the beta of the portfolio times the market risk premium. And then Fama and French came along and said, look, there is a size coefficient. This is small minus big, so there's a size effect. and then they had this H coefficient because it's HML, it's high minus low, high book value minus low book value. That was Fama and French, and then another one was added, the momentum effect. This is, of course, as we well know, up minus down. So to run this, now you run this regression, and so the information I have is, instead of what you had before, you just had this portion before, but now I'm saying let's add some risk factors, and so we have all of them. And you can see here, this is essentially the same thing mathematically. I'm just adding different risk factors. So think of it this way. This is what we'll call market risk. Let's call this size risk. Let's call this value risk. Let's call this momentum risk. All right. So as a portfolio manager, if I think you're not very sophisticated, you know, I can sit here and I can look at this, and I can say they're going to judge my performance just on the one risk factor. They don't know the other risk factors exist. So I'm going to take more size risk or more value risk or more momentum risk, and they don't know it. So if these numbers are positive, any three of them, and you're not accounting for them, it makes the alpha look bigger, correct? When it really shouldn't be. So what we did here is we found the alpha was 0.0150. We're in the exact same regression, but now I add my additional risk factors. The alpha is smaller, is 0.0133. Now let's look at the beta. So this 0.7340 term right here, this is beta. It's significant because the p-value is very small. And remember, if the p-value is less than 10, it's significant at the 10% level, which means I'm 90% sure that the estimate is different than 0. If p is less than 5, it's the 5% significance level. 1% level, which means I'm 99% sure. So here I'm more than 99% sure that beta is greater than 1. The p-value here is very large, so I can say really you took no size risk. This was 0. By the way, the stocks that are in this portfolio were stocks like Apple and Microsoft, so large stocks. The p-value here is small. It's not quite at the 1% level, but it's pretty close. So I'm 98.26% sure that the value risk was negative. Momentum risk, p-value is very large, so this is essentially 0. So even though Fama and French didn't come up with this last term, I'm going to call this the Fama French alpha. So on the test, what's the Fama French alpha? It's 0.0133. And if I want you to annualize it, multiply by 12. And then I could ask you which risk factors were significant, right? And you would say, well, beta was significant, and H was significant, S was not, and momentum was not. Okay, one more thing to show. Let me pull up another little bit of data. Okay, so here's another bit of data. So we have almost the same given information here, and so the regression that I ran here is, I'm calling this U. I'm calling this U minus the benchmark. So that is, you're my portfolio manager. Here are your returns. I could have invested in the benchmark. So let's say you're my small cap manager. Say, look, instead of paying you big fees, I'll just buy the ETF for the Russell 2000, right? And I'm not paying anybody management fees. So what I want to do is take your returns, subtract the benchmark, and then I'm going to run the same regression, alpha plus beta, RM plus S times SMB plus H times HML plus M times UMD. So I'm saying again, here is, I want this alpha to be positive. Well, let me show this over here. You, in January, you lost to the benchmark. It outperformed you. You lost in February. But these 3 months, March, April, May, June, you outperformed the benchmark. Look, you outperformed in the 1 month by 6% in May. So overall, I want to see that this is a positive number, right? So not only do I want to see that that's a positive number, it's not enough to come out and say you, on average, beat the benchmark. Did you take more risk? Right? So I want to see if you took more risk, and I want you not to get more returns, but more risk-adjusted returns. So that's what the alpha is. If alpha is positive, then you got better risk-adjusted returns than the benchmark. Because the theory here is, look, maybe small stocks all had positive alphas, and our market is the entire market. It's all the S&P. It's everything that trades on the NASDAQ, on the New York Stock Exchange, and the American Stock Exchange. It's all those stocks. So alpha is positive, and it's significant. It's not significant at the 99% level, but significant at the 95% level. So I may ask you a question, what was your alpha? Well, it was 1.34%. I may ask you to annualize it. Was it significant at the 95% level? Yes. Was it significant at the 99% level? No. So generally I'll ask you 90, 95, or 99% level. And then if you're my portfolio manager and say I want you to invest in a certain style, and that style that I want you to use to invest in will be measured by the amount of market risk you take, which will be represented by the beta, the amount of size risk you take, the amount of value risk you take, and the amount of momentum risk you take. So in this equation, beta should be equal to 0, size risk, the S, should be equal to 0, H should be equal to 0, and M should be equal to 0, because you should be taking the same market risk, same size risk, same value risk, same momentum risk. These numbers down here are never going to be exactly 0. So let's look at the p-values. P-value is very large. This is essentially 0, so check mark for momentum. This is p-value small, p-value small, p-value small. All these, so you took a different, and you took less market risk, less size risk, less value risk. And that's it for performance measurement. Just last review, the Sharpe ratio, the trainer measure, Jensen's alpha, the Fama and French alpha, and then the very last thing, I'll say the difference, alpha from RP minus RB for the benchmark. So all of these you will need to see regression output. So I will give you regression output on the exam, and I will say, here's the regression I ran, and I will give you an equation like this. And then from output that's given here, you need to be able to answer the questions. For the Sharpe ratio, you need to take, notice the average and standard deviation. Maybe I'll give you, I'll make it so you don't have to do a lot of calculations just so you can get this point. And that'll be it. So good luck. Let me know if you have any questions. And one last thing, I've had a lot of trouble uploading recently, so hopefully this uploads fine. We'll see.